Hello students, I'm Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Now as you know, we are learning how to find the solution set of different inequalities, and in our today's session we will be learning how to find the solution set of rational inequalities. It is solving rational inequalities on a number line. You may get the solution set of a rational inequality using a graphics calculator, or you may sketch the given rational expression to find the solution set. In our today's session, we will be using the number line to find the solution set of the given rational inequality. But what do we mean by this term rational inequality? We will be knowing about this very soon. So without any further delay, let us start with our today's session. First of all, let us look at the given question. It is solve x plus 2 over x minus 4 greater than equal to 0. Now this is a rational expression which is of the form of a fraction. You are having an algebraic expression in the numerator and another algebraic expression in the denominator. And in this case, we are having two linear expressions, but it is not mandatory that you have to have only linear expressions. They may be quadratic expressions, they may be cubic expressions. The numerator may be quadratic, the denominator may be linear. X can have any power, okay? But it should be in the form of a fraction in order to be a rational expression. Okay, or we call this a rational function. I am not using this word rational function, this term rather, because I have not done any video session on functions. So I am assuming that you may not be knowing many things about functions. So I am just trying to avoid this term functions. Okay, so now we have been given an inequality x plus 2 over x minus 4 greater than or equal to 0, and we have to find the solution set of this inequality. So let us move to the rules part. The first rule says find the vertical asymptote and the x-intercepts. Now the vertical asymptote is that value of x which the function cannot have as its input. Now again, I am sorry I have used this word function, but stating in a simple form, you cannot have that value of x. If you have a particular value of x which you cannot take, that value of x will be the vertical asymptote. Like in this case, why cannot we take a particular value of x? Because of this denominator. We cannot have a 0 in the denominator. So x minus 4, if this is equal to 0, then the x value should be equal to 4 because 4 minus 4 is equal to 0. And we cannot have a 0 in the denominator, hence we cannot have the value of x as 4. X is a variable, so it can take any value, but it cannot take the value of 4 because if it takes the value of 4, then the denominator will become equal to 0, which we cannot afford to have. So the x value which cannot be taken will be the vertical asymptote. Okay? And what are the x-intercepts, or what is the x-intercept? X-intercept or x-intercepts are those values of x which makes the function expression equal to 0. Again, I have come to that function term. The given expression equal to 0. It may be a simple algebraic linear expression, quadratic expression, in this case a rational expression. But that expression should be equal to 0. The values of x which make that expression value equal to 0 are known as x-intercepts. Okay. So we have to find the vertical asymptote and the x-intercept of this expression. We have found the vertical asymptote in fact because we have seen that x cannot have the value of 4. So this is the vertical asymptote which is equal to 4 and the x-intercept. The x-intercept or x-intercepts, if you have multiple x-intercepts, you may have multiple x-intercept, that is, you may have more than one value of x that will make the function or the expression value equal to 0. Okay. So in this case, when will this rational expression be equal to 0? When the numerator equal to 0? When the numerator is equal to 0, the expression value becomes equal to 0 because we cannot have 0 in the denominator. The value for x which makes the denominator equal to 0 is the vertical asymptote. And the value or values for x, like if there is a quadratic expression in the numerator, you will be having more than one value of x, which will be making the numerator equal to 0. Since this is a linear expression, we will be having a single value of x, which will be making this numerator equal to 0. It will be x plus 2 equal to 0, so x equals negative 2. So this is the x-intercept of this rational function or rational expression. The x-intercept is equal to negative 2. Okay. Rule number 2. Draw the sign diagram to find the answer. We have learned how to draw the sign diagram. So we are drawing, this is the number line. I have taken this to be x. Actually, it is a number line. It is having all real number values, not only x. It is ranging from negative infinity to positive infinity. Okay. So, and we have to find those values from this number line, which will be obviously the values of x, which will be making this inequality true. Okay. So that is why I have written this x, because these are all x values. We may assume them to be the x values, but the solution set will be some parts or some real numbers taken from the whole set of real numbers. That is the number line. Okay. So what do we do? See, x-intercept is negative 2. So we are having this line on top of this negative 2. This is a solid line. And vertical asymptote is positive 4. Now you see the difference. This one, since this is the x-intercept, it is a solid line. Because the expression if graphed will be passing through this point x equals negative 2. But since the vertical asymptote is 4, x equal to 4, you can never have x equals 4. Therefore, the expression graph will not be passing through x equals 4. So you see on top of this 4, we are having a dashed line. This is the difference between an x-intercept and a vertical asymptote. Always we represent a vertical asymptote by a dashed line and a x-intercept by a solid line. Okay. Now these two are dividing this entire number line into 3 parts, and as we know, we have to take one value for x from each of these 3 parts, and we have to substitute that value in the given expression, and we have to find the sign of the answer, the result. So from the leftmost part, I have taken x equals negative 4. And in place of x, I have written negative 4. It is negative 4 plus 2 and negative 4 minus 4. So minus 4 plus 2 is minus 2 over minus 8. So you are having a negative number in the numerator, a negative number in the denominator. Hence, the answer will be a positive one. And we are only concerned with the sign, so I'm just writing plus. I'm not concerned with what number are we getting, which will be written just after this plus sign. If we write the number, in fact, we ignore the plus sign leading positive sign. We never write that. But in our case, when we go for the sign diagram, we are only concerned with the sign. So we are writing this plus sign, not the number. Next, from the middle region, I am taking the x value as 0. You can take other values as well. And 0 plus 2 over 0 minus 4. It is 2 over negative 4, which is negative half, so a negative number. And from the right side, I am taking x equals 6. So 6 plus 2 and 6 minus 4. 8 over 2, a positive number. So this will be giving us a positive value. And we need a positive value. And we are having this equality sign included as well. Okay. So when we have this equality sign included, we take the x-intercepts, we include the x-intercepts in the solution set, but we can never include a vertical asymptote because that is the value of x which we cannot have, because that value will make the denominator equal to 0. So we cannot include the vertical asymptote value in the solution set. But since there is this equality sign included, we will be including the x-intercept or the 0 in the solution set of x. Okay. So therefore, we will be taking x can have any value which will be less than or equal to negative 2. Obviously, this left-hand side is satisfying this inequality and this right-hand side is also satisfying this inequality. So, x can be any number greater than 4, not equal to 4. You should be careful about this. Okay. So, now coming to the final answer. X is less than or equal to negative 2 or x is greater than 4. This is the answer written in inequality form, or else if we want to write the same answer in interval notation form, it is x belongs to the negative infinity because you may move to the left as much as you want and you are moving towards negative infinity. So it is negative infinity comma negative 2, but negative infinity is not any number. This cannot be included. So we are having this parenthesis notation. But negative 2 is included, hence the square brackets. In place of or, we are having this union notation. And 4 cannot be included. And we are heading towards positive infinity. We are moving towards right side because means we are heading towards the positive infinity. And we cannot include positive infinity as well. Positive infinity is not any number. So we are having these two parentheses. Okay. So this is our final answer for the given rational inequality. Okay. So students, this is all for our today's session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.